Hi, I'm Gyeong-sik from Meta. Let me introduce our paper, Bringing Inputs to Shared Domains for 3D Interacting Hands Recovery in the Wild, accepted by CVPR 2023. We humans often make two-hand interactions in our daily life. During having conversations with other people, like the left figure, we often make two-hand interactions with no special meaning. We also make two-hand interactions with special meaning, such as pray, as shown in the right figure. There have been many attempts to recover 3D interacting hands from a single RGB images, but most of them have focused on results on mocap datasets, such as the Interhand dataset. Such mocap datasets have 3D ground truths, but have severe appearance domain gap from InterWild images. For example, as shown in the left figure, images from Interhand dataset have limited backgrounds and lightings. On the other hand, InterWild images like the right figure have diverse background and lightings, but they do not have corresponding 3D ground truths. The problem that this paper aims to solve is this question. How can we recover 3D interacting hands from InterWild images without 3D ground truths from them? 3D interacting hands recovery consists of two sub-problems. First, recovering 3D hand of each right and left hands. And second, 3D relative translation between two hands. By combining the outputs of two sub-problems together, we can get final 3D interacting hands. For the first sub-problem, previous work take two-hand images and fully supervise the network with two-hand 3D meshes. For the generalization to InterWild images, the network should be jointly trained on mocap and InterWild datasets. Collecting and annotating two-hand interacting data from InterWild environment is not trivial even for the 2D data case, due to self-similarity and severe occlusions between hands. This makes existing InterWild datasets mostly contain single-hand data, a small number of interacting hand data, as shown in the right figure. Therefore, most of the input samples from InterWild datasets will be single-hand ones, not two-hand ones. Such a combination of two-hand data from mocap datasets and single-hand data from InterWild datasets suffer from 2D scale domain gap, as shown in the right figure. When two hands are included in the input image, a 2D scale of each hand is smaller and inconsistent compared to those of single-hand images. Instead, we bring inputs to a shared 2D scale space by designing a regressor to take a single-hand image, regardless of whether they are interacting or not. By normalizing 2D scale of inputs, our network suffers less from the domain gap between mocap and InterWild datasets. The second subproblem is recovering 3D relative translation between two hands. To this end, previous works take two-hand images as input and fully supervise the network with 3D ground truth translation. As InterWild dataset do not provide 3D ground truths, sample from InterWild dataset should be weakly supervised with 2D joint coordinates. But actually, this makes some problem. The combination of purple and green hand represent correct estimation given a single input image. On the other hand, the combination of orange and green hands is a wrong one, but could also happen given ambiguity of the 2D-based weak supervision. Such kind of ambiguity is particularly a problem for the 3D relative translation between two hands, as the 3D translation is not restricted at all in some latent space. For example, we can put two hands in any distance and any direction depends on how they are interacting with. Therefore, very unlikely 3D relative translation between two hands, like the combination of orange and green hand, could happen if it is good for minimizing the 2D base loss function. On the other hand, 3D pose of each hand suffers less from this ambiguity, as the 3D shape of each hand is limited in the 3D hand model. Although the weak supervision could cause some ambiguity up to the 3D translation, just removing it is not a good solution. Without a weak supervision, InterWild samples are not exposed to the regressor. Therefore, a regressor trained only on mocap images would not generalize to InterWild images. So we resolved the two problems, removed the weak supervision, and made the regressor generalize well to in-the-wild data. For this, we designed the regressor to take 2.5D pose of two hands without images, and do not apply the weak supervision. As 2.5D pose only contain geometric information without image appearances, a regressor trained only on mocap dataset can generalize well to in-the-wild data. Let me show the overall pipeline of the proposed system. From a human image, we detect hand boxes. Each hand is cropped and resized and passed to SHNet, which takes a single hand image regardless of whether they are interacting or not. Therefore, inputs of SHNet are in shared 2D scale space. Then, 2.5D poles of each hand are passed to Transnet for the 3D relative translation estimation. The 2.5D poles of each hand are in shared appearance-invariant space. Final 3D interacting hands are obtained by moving the left hand mesh by the 3D relative translation. Let me show some ablation studies. First, this one shows the effectiveness of taking a single hand image of SHNet for the first subproblem, which is recovering 3D hand of each left and right hands. By taking a single hand image, SHNet's input have a uniform 2D scale. Second, this one shows the effectiveness of taking a 2.5D pose of Transnet for the second subproblem, which is recovering 3D relative translation between two hands. By taking a 2.5D pose instead of image, our Transnet generalized much better to HIC dataset. In addition, the table shows that the weak supervision is always bad for any input types. Our InterWild outperformed previous works, especially on InterWild HIC dataset. The below figures show that regardless of distance between two hands, our InterWild outperformed previous works on the HIC dataset. These are qualitative results. Our InterWild produces highly robust results compared to previous state-of-the-art method. As there have been no method for 3D interacting hands recovery in the wild, we retrain a previous state-of-the-art method jointly on mocap and the wild datasets. These are additional qualitative results. Thank you for listening.